In this quick video, we are going to explore how Java works, from the moment you write your code to the point where your program is up and running. Java is one of the most popular programming languages in the world. It's known for being reliable, fast, and platform independent, which means you can write your code once and run it anywhere. But how does that actually happen behind the scenes? In the next few minutes, we'll walk through the full Java workflow, step by step, so you can understand exactly what happens when your Java code comes to life. Let's get started. Everything starts in the code editor. This is where you actually write your Java code. Let's say you write a simple program like printing hello world. You save that code in a source file with a .java extension. So if your class is called hello world, your file will be named helloworld.java. At this stage, the code is just plain text. It hasn't been converted into anything the computer can run yet. Next, we need to compile that code. Java comes with a compiler called Java, short for Java compiler. It takes your .java file and translates it into bytecode, which is saved in a .class file. Now here's the cool part. Bytecode is not specific to your computer or operating system. It's written in a kind of universal language that the Java virtual machine or JVM can understand. So your original code goes from human friendly to machine prepared. Once we have bytecode, we pass it to the JVM or Java virtual machine. This is where things get interesting. The JVM is part of the JRE or Java runtime environment. The JRE includes the JVM plus all the built-in Java libraries your program might need to run, like math functions, date and time utilities, or graphical tools. The JVM reads the bytecode and prepares it for execution, but it doesn't just interpret it line by line. Java also uses something called the just-in-time compiler or JIT. Here's what the just-in-time compiler does. Instead of interpreting the bytecode every single time your program runs, the JIT compiler translates it into machine code, also called binary code, right when the program needs it. This makes Java much faster than traditional interpreted languages because the heavy lifting only happens once, and after that, the code runs almost as fast as native apps. Think of it as real-time optimization. The JIT compiler watches how your program runs and then improves performance on the fly. Finally, once the bytecode is translated into machine code, the computer knows exactly what to do. Your program starts running, whether it's printing messages to the screen, doing calculations, or controlling a full desktop application. All of this happens seamlessly because of how Java is designed. Write it once, run it anywhere. That's the power of the JVM and bytecode together. Let's quickly go over what we've learned about how Java works. First, you begin by writing your code in a code editor and you save it as a file that ends with the word .java. Next, that file is sent through the Java compiler. The compiler translates it into something called bytecode, which is saved in a file that ends with .class. Then the Java virtual machine, also known as the JVM, takes that bytecode and works together with the just-in-time compiler to convert it into machine code that your computer can understand and run. Finally, your program runs using built-in Java libraries to do things like display messages, perform calculations, or interact with files. This entire process, from writing to compiling to running, is what makes Java so portable, so efficient, and so powerful. It's also why Java continues to be one of the most widely used programming languages in the world. Thanks so much for joining me, and I'll see you in the next video.